The James Webb Telescope has basically revealed the clearest photograph of Proxima B in records, uncovering lovely bits of know-how into a probably tenable exoplanet. It obliges us as we set out on a journey through space to find the secrets and techniques of Proxima B and discover whether it is able to be the next Earth. We should take off into the huge expanse of space where a mysterious planet exists inside the habitable sector of its star, Proxima Centauri. This planet isn't simply any ordinary rock. It is real. Proxima B is found in insignificant 4.2 light-years from us. This planet is blanketed in mysteries and wonders. Could it be another Earth, with seas and life blossoming on its surface? Anyway, wait, there's more. Proxima Centauri B isn't alone in that system. Across the red dwarf star, it has a companion, Proxima Centauri C. And who knows what other mysteries the star system holds. Perhaps there may be another companion that we haven't yet observed. The secret doesn't stop there. Proxima Centauri produces roughly the same amount of energy from its star as Earth does from the Sun. This really suggests that there is water on its surface, and possibly even life. As we explore beyond our very own solar system, we stumble upon a completely new universe of exoplanets, planets that orbit stars other than the Sun. With 200 billion stars in the universe, the opportunities for exoplanets are infinite. Some exoplanets even wander freely, untethered to any star, like wandering vacationers in space. Among all of them, Proxima Centauri B stands out as an especially intriguing and fascinating planet, with a year that lasts only 112 Earth days and a distance from a star that is usually closer than Earth is to the Sun. Certainly, one side of the planet is constantly washed in daylight, while the opposite side stays in everlasting darkness. Now let's examine Proxima Centauri, the star that Proxima B orbits. Proxima Centauri is a part of the Alpha Centauri triple star system. This system includes Rigel, also known as Alpha Centauri A and Alpha Centauri B. Together, these stars form the closest star system to our solar system. The two stars, Rigel and Alpha Centauri B, form a binary system called Alpha Centauri A and B. These G and K-type stars appear as one star in the constellation Centaurus and are the third brightest stars in our night sky, with a peak luminosity of under 2.7. Proxima Centauri, also known as Alpha Centauri C, is a red dwarf or M-type star found 21 light-years from the other stars, typically about 4 times the space between Earth and the Sun. It is the closest star to us. Proxima, in fact, means the nearest star in Latin, and was observed in 1915 by Scottish astronomer Robert Thorburn. Notwithstanding being our closest celestial neighbor, it is not visible to the naked eye, having an apparent magnitude of 11.13, which is much fainter than the human eye's limit of 6.5. Anyway, don't let that fool you. Proxima Centauri remains a star worth studying. Red dwarfs like Proxima Centauri are among the most efficient in terms of energy production. They may not produce a lot of energy, but the interconvection processes at their cores keep them shining for trillions of years. Generally speaking, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf star like Proxima Centauri is still debated. For one, it's a flare star, meaning it has frequent and intense explosions. As a low-mass star, its habitable zone might be much closer to it than the Sun's, projected to be somewhere in the range of 0.23 to 54 cents. However, it's not as livable as it seems. Proxima B is bombarded by high ultraviolet radiation from its star, radiation stronger than the radiation we get from our Sun. That's right. It's so intense that even the lightest debris of hydrogen are stripped away, along with nitrogen and oxygen. But that's not all. Just because a planet is at the right distance from its star doesn't mean it can support life. Proxima B may not have a strong atmosphere, which is crucial for regulating temperature and maintaining a water-friendly surface. Without it, living creatures might be exposed to harsh space weather conditions, making life almost impossible. So while Proxima B might appear Earth-like on the surface, it is far from being able to support life. Scientists remain highly cautious, as there are many factors that render it inhospitable. The mission to uncover the truth about Proxima B continues, and some still hold hope. One device that has garnered the attention of astronomers is the James Webb Telescope. After years of anticipation, the telescope was finally launched in 2021 and will help us determine if there is life on Proxima B. But as with everything in science, things are never as simple as they seem. Several adjustments were needed to ensure the James Webb Telescope provides accurate images. As Abby Tabor, a theoretical physicist at Harvard, explains, if a planet like Proxima B can absorb light from its star, it may also emit it as infrared light. The James Webb Telescope was specifically designed to detect infrared light and can capture images of this light from the planet's surface, searching for patterns that might confirm the presence of water or an atmosphere. But what if the planet has an atmosphere that is not conducive to life? The presence of an atmosphere doesn't guarantee the presence of life, cautions Ed Turner, an astrophysicist at Princeton University. Proxima B might be like Venus, with a thick atmosphere that is considerably denser than Earth's and extreme temperatures that could make it impossible for life to exist. The journey to unravel the mysteries of Proxima B is not without its challenges. While the James Webb Telescope holds promise, there are other factors to consider. With costs mounting, space scientists are feeling the pressure to find ways to examine planets like Proxima B. Much is at stake, but the rewards are even greater. The opportunity to explore the unknown, to find the secrets of a far-off planet that holds the potential for life, is a pursuit worth chasing. If the exoplanet were livable, might we someday visit it? It is the closest exoplanet to us, which makes it so fascinating, practically like exploring our own backyard. Even more interesting is that it's roughly the identical size as Earth. Its function inside the livable zone indicates it is able to certainly have conditions appropriate for life. Proxima B's proximity also makes it a super target for our quest for existence beyond Earth. With it being so near, it's a high candidate for interstellar missions. Reflect on exploring this Earth-like exoplanet. Despite the fact that we cannot yet move there, it's certainly on the radar for future missions. As technology advances, it is one of the most thrilling endeavors within the field of space exploration. But it's no easy undertaking. It would take 75,000 years for a spacecraft like Voyager 2 to reach the Proxima Centauri system. Nonetheless, a solution has been proposed: solar sails. These extremely thin sails can be used to propel a spacecraft to the Alpha Centauri system and Proxima along with it. This technology uses solar pressure to keep the spacecraft on course, eliminating the problem of running out of fuel. And here's something even cooler. This cutting-edge technology could offer insights into the possibility of life on other planets like Proxima. However, like anything ambitious, there are barriers. For example, the presence of an atmosphere does not necessarily guarantee the presence of life. Proxima B could be like Venus, with a thick, hot atmosphere that is inhospitable. Furthermore, get this, the James Webb Telescope can locate such emissions if it reaches a brightness of only 5% of the sunlight. Now, 5% may not look like much, but when dealing with a star that is normally dimmer than our own sun, it's quite significant. If Proxima B has advanced civilizations, they'll use bright orbital mirrors to reflect sunlight from the daylight side to the nighttime side. How cool is that? There are infinite exoplanets waiting to be discovered in our universe. These planets come in all sizes and shapes, with some being big gas giants, while others resemble our very own Earth. But what can we understand about them? One type of exoplanet that has caught the attention of space scientists is the gas giant. These planets are comparable in composition to Jupiter and Saturn, but are much larger. A number of these behemoths have been named super-Jupiters, surpassing even the biggest planet in our solar system. Yet it's not all. There are also hot Jupiters, gas giants that orbit extremely close to their host star, existing in a sizzling world with temperatures that would melt steel. Imagine seeing one of these planets up close, with its furious storms and extreme heat. In addition to gas giants, there are also Neptunian exoplanets, which are similar in size to Uranus and Neptune. Among these are the hot Neptunes and small Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in mystery, with their atmospheres being tough to study from a distance. And let's not forget the Earth-like exoplanets, which resemble our own Earth. These planets come in various sizes, ranging from smaller than our planet to twice its size. There are even super-Earths, which have masses more than twice that of our planet, but are lighter than Neptune. One of the most fascinating exoplanets recently discovered is Proxima Centauri b, which orbits the famous star of the same name. This planet is classified as a super-Earth, with an estimated mass of 7 Earth masses. It orbits in the habitable zone of its host star, and scientists are currently investigating whether it could support life. Proxima Centauri b is of particular interest because it is the nearest potentially habitable planet to our own solar system. As we continue to explore these captivating worlds, the James Webb Telescope promises to offer even more insight into their potential for life and habitability. The allure of Proxima Centauri b lies not only in its proximity, but also in the tantalizing possibility that it could harbor conditions conducive to life. As we probe deeper into the exoplanet's characteristics, the question on every scientist's mind is whether Proxima holds the keys to understanding whether life can exist beyond Earth. While it may be a rocky world, its orbital position in the habitable zone and its potential water presence make it an exciting target for future exploration. However, there may be a catch. The proximity of Proxima Centauri b to its star means that it could be subject to risky radiation, especially since red dwarf stars like Proxima Centauri are known for their violent flares. These flares, which emit extreme bursts of radiation, could strip away a planet's atmosphere over time, making it difficult for life to take root. Proxima may also face tidal locking, a condition in which one side of the planet is always facing the star while the other side remains in darkness. This could lead to high temperature variations between the two sides, complicating conditions needed to support life. But there are still many uncertainties. We do not fully understand how the planet's atmosphere interacts with its surroundings. For example, could Proxima b have a protective magnetic field that would shield it from the star's radiation? This could be crucial for sustaining life on the planet. Furthermore, the possibility that life, if it exists on Proxima b, could have adapted to the harsh environment cannot be ruled out. Life on Earth, after all, has managed to thrive in even the most extreme conditions, from the depths of the sea to the frozen tundra. Could Proxima b harbor a different form of life, one that thrives in the face of challenges we cannot even yet imagine? In addition to these considerations, Proxima b's proximity to Earth makes it a prime candidate for interstellar travel, especially with future advancements in space technology. While our current spacecraft like Voyager 2 might take tens of thousands of years to reach the system, more ambitious initiatives are being proposed. Solar sail technology, for example, offers a potential solution. Using the pressure exerted by sunlight, solar sails could propel spacecraft at a large fraction of the speed of light. This method could bring us closer to realizing the dream of sending probes to explore remote exoplanets like Proxima Centauri b. The possibility of someday sending people to Proxima b is an even more tantalizing opportunity. While this prospect remains far off, it fuels our imagination and underscores the importance of continued exploration and research. For now, the James Webb Space Telescope will serve as our eyes into this distant world. It will monitor Proxima's atmosphere, study its surface, and gather critical data to help us determine whether it can support life. Through its infrared capabilities, Webb can provide us with valuable insight into the planet's weather patterns, composition, and more, bringing us closer to understanding whether Proxima b could eventually be a second home for humanity. As we move forward, it is clear that exploring exoplanets like Proxima b offers more than just a chance to find alien life. It also represents our desire to understand the universe and our place within it. Every discovery, every piece of the puzzle brings us one step closer to answering fundamental questions about life, the cosmos, and what the future holds for humanity. Whether Proxima b proves to be habitable or not, the journey of exploration will continue to inspire and shape our future.